Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Also, this probably isn't going to be very popular, but I enjoy doing these tessellations. I know many people don't seem to enjoy these as much, so it is what it is. I'm still going to be doing it, and this will be today's easy puzzle. Let me know if you guys want an additional easy puzzle when you have like tessellations, because if that's the case, I'll try to do these as special puzzles in the future. But I just really enjoy these, and I don't know. I hope more people enjoy them, but it just seems like it's not as popular. Anyways, let's get to the puzzle itself. It's called Index Lines and a 9 Tessellation by Chinstrap. And here are the rules. We have tessellation, where we need to fill each cell in the grid with a digit from 1 through 9, with a single digit from 1 through 9. And cells sharing an edge cannot have the same digit. So since this digit is a 9, there cannot be a 9 in the 8 surrounding cells that share an edge with it. Also, each horizontal row and vertical column contains a non-repeating consecutive set of digits, like 2, 3, 4, 5, 6 in any order. So, for example, in row 3, it's going to have to be 5, 6, 7, 8, 9, because that's the only set of consecutive digits, non-repeating, that contains 9 for the digits 1 through 9, right? 5, 6, 7, 8, 9 here is the only one that works. So that should tell you a decent amount of information. And finally, we have index lines, where the value of the nth cell along a line, starting from the diamond, which is here, indicates the position along the line where the value n appears. For example, if a diamond cell has a value of 3, the third cell along that line must have a value of 1. And the lines share a diamond but are otherwise treated separately. So this is one line here, and this is one line here. So if this were 3, that would mean the third cell on the line has to be 1 here, and the third cell on this line must also be 1. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, how long are these lines? So we have 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, 7, 8. So this digit has to be 1 through 6 because it cannot be longer than the line itself. And these must be also 1 through 6. These can be 1 through 8 here. And this specifically has to be 5, 6, 7, or 8 because this row must be the digits 5 through 9 to be a Renban, essentially, to form a consecutive set. So that means along this line, 5 has to be somewhere on 6, 7, or 8. So we have a guaranteed 5 here, which means 5 cannot be anywhere else on this index line. If it were, then that doesn't match because 5 would have to be pointing to that that line. Okay. So this could be 1. What? That's the only thing we have, huh? Interesting. Hmm. We do know in row 3, column 3, column 7, and row 7, there's guaranteed a 5. So there must be a 5 in one of these cells. There's obviously a 5 in one of those. There must be a 5 in one of those cells. There must be a 5 in one of these cells. Does that help us much? I don't really know. What happens? Okay. Hmm. What happens if there's 8 here? If this is 8, that means 5 must be there. So 5 cannot be here, so 5 would have to be one of these two. None of these could be 5. Because they share an edge with this 5. So 5 would have to be here. And this would have to be 4 or 6 here. 5 and 8 could not be here, so this is 6 or 7. So 1 would have to be one of these two if that were the case. So 5 could not be here, 5 could not be here, 1 could not be either of these two, and could not be here. So obviously these could no longer be 5. This can't be 5. So if that means this cannot be 6 here. Oh no, it's 1, right? We're looking for 5. 5 cannot be here. So this cell means you cannot be 1, 2, or 6. So this would be 3, 4, 5 as the 5 here. This obviously can't be 5 anymore. This can't be 5 anymore. This can't be 8. One of these two digits is a 5. And we know one of these two digits is a 5. We know one of these two digits is a 5, so this cannot be 5 here. One would have to be in 4 or 6, which means then this cannot be 8. This would have to be the digits 1 through 7, but 2 through 7 here, 2 through 7 here, 2 through 7 here. One of these is 5, so this cannot be 5. Therefore, 4 cannot be here. So this is 3 or 5 here. So we're guaranteed a 1 in one of these spots. 1 has to be one of these two, so this is 1 through 7 also. This can't be 5. This has to be 1, 2, 3, 4, 6, 7. 1, 2, 3, 4, 6, 7. 2, 3, no 1. 2, 3, 4, 6, 7. And these are 2, 3, 4, 6, 7. This is not leading to the contradiction I was hoping it would. um. Hmm. Hmm. Okay. Let's go back. Let's look at other possibilities. Hmm. These digits must be what? 1, 2, 3, 4, 6, 7, 8. So this can be at most a 7 here. So this is 1 through 7. What happens if this is 1? If this is 1, that means this must be 5, and this must be 2, 3, and 4. Interesting. So that means 1 cannot be here. 5 cannot be here. 5 cannot be here. So, obviously 5 can't be here. These cannot be 1. That doesn't really tell us too much. These become 2, 3, 4, 6, 7, 8. Right. This is 1 through 5, so this cannot be 6 here. So 5 cannot appear there. These are 2 through 5 here. Okay. Doesn't really tell us much. That's not seeming to lead to a contradiction. Okay, that's not leading us much. What about if this is 2? If this is 2, this is 1 guaranteed, 1 guaranteed. Oh, that's interesting. That means this must be 1, 2, 3. So the problem, though, with that is, so that's saying 2 is in the... 1 has to be in the second position, which it is. 2 has to be in the first position, which it is. That means this must be 1, 2, and 3. This can't be 2 because that's saying 2 would have to be in the fourth, or 4 would have to be in the second position, which it's not. So this must be 3. That's 2. That's saying 3 has to be in the 4 has to be in the third position, so that's 4. So then this is 5 and 6 here. And this would also have to be 1, 2, 3, obviously. So that would be 3 here, which makes a 4 there. So this is 2. Okay. This has to be either 1 or 6, right? No 2. This is not 7 or 8, so 5 or 6 is here. 5, 6, 7, 8, 5, 6, 7, 8, 5, 6, 7, 8. This has to be 2 through 6 with, or 1, 3, 4, 5, 6. This can't be 1, this can't be 1, this can't be 3, this can't be 3, this can't be 4. We have a 5, 6 pair in column 7. That eliminates 5, 6 in the rest of the column. So this cannot, this has to be then 2, 3, 4, 5, 6. So this is 4. This is 3. This 5, 6 pair eliminates 5 and 6 here as a possibility because these are different 5 and 6s. So this must be 7 or 8. So 5 cannot be in the 6th spot, so 5 has to be in the 5th spot. So this is 5, which makes this not 5, and this not 5, so this must be 6. But that eliminates 6 on this index line altogether, so then this would not work. So this cannot be 2 because of that. That's kind of long, convoluted way of doing that. So this cannot be 2. What happens if it's 6? 6 isn't great either. This can't be 1. Cannot be 1. Because 1 cannot be in the 5th spot here. Because it can't be here, right? If there's 5, that would be 1, 2, 3, 1, 2, 3, 4, 5. So 1 would have to be there, but that's not possible. So that doesn't work. Okay. So we've shown 2 does not work. 3 seems like it works okay. 4 is a little problematic. So let's try 4. That means this is 1, this is 1. So then this becomes 2 and 3 as a pair. But that would be saying 2 has to be either in the 2nd position or the 3rd. Okay. So then that would force this to be 2 and 3, which means this could not be 2 and 3. Same with this. This would be 2 and 3, which means this could not be 1, 2, or 3. Cannot be 4. So 3 has to be 5 and 6. Therefore, this can't be 3, because that would say 2 has to be there. So this must be 2. This is 3. 5 and 6. That means this is what? 3, 5, and 6 remaining. This would have to be 5, 6, 7, or 8. 3 would say 2 would have to be there, but it can't be. So this is 2. That's 3. We have 4 here. That means the remaining digits, so cannot be in 5. So it has to be 6, 7, or 8. So we have 3, 5, 6, 7, 8. 3 cannot be here, so 3 can only be in 6 or 8. So this is 6 or 8 here. Okay. This is 2, so you cannot have a 9 here. That doesn't tell us very much. So this does seem feasible. Okay. So 4 doesn't seem to overly restrict us. Interesting. So we're guaranteed a 3 in one of these cells. That also doesn't help us. What happens if we try to have 1 through 5 here? Obviously 1 can't be here, so this is 1. 2 can't be here or here, so this must be 2. 3 can't be here, so this is 5, which makes this 3. And that makes this 6. Which says that 3 has to be in the 6th spot, which it's not. It's in the 5th spot. So that fails. So then this cannot be 1 through 5. Same problem here. Yeah, you have 5 here. 1, 3, 1, 2, and then this can't be 3. So this cannot be 1 through 5. But that just disproves that we can't have 1 through 5 there. That doesn't help us very much. Hmm. That doesn't seem to work. I mean, that doesn't seem to lead to a contradiction, really, is the key. We're looking for contradictions here because I don't know if there's very much any other way of doing this. Hmm. So say we had, I don't know. Say we had this as 7, then that would force this to be a 5-6 pair here. Which would mean 2 and 4 have to be in 5 and 6. So that'd be 2 and 4. Therefore, we have 1, 3 here. We cannot have 5 here. We can't have 5 here, obviously. Excuse me. This can't be 5, 6, or 7. So it's 1 through 4. It cannot be 8 because 8 would have to have cannot be with 3 and 4 to form a 5-length Renban. So we're guaranteed 5 here. We're guaranteed 5 in one of these two. So that eliminates 5 in the rest of column 4 and 6. So this can't be 5. This can't be 5. Which means 5 is only in 5 or 7 here. One can only be in 1 or 3, so this cannot be 1 here. This cannot be 1 here. This has to be 2, 3, 4, 5, 6. So this is 1 through 6 then. 1 through 6. This 2, 4 pair eliminates 2 and 4 in this cell. This one sees it by the same row. This one shares an edge. So it cannot be 2, 4. We have a 1, 3 pair in row 7, so that eliminates 1, 3 in the rest of the row. So this must be 2, 4, 5. This cannot be 2 and 4 because it shares an edge with two different 2 and 4, so this must be 5. This cannot be 5 here. Therefore, this is 2 or 4. This 5 eliminates 5 here, so it's 6, which makes this not 6. That's 5. That forces this not to be 6 either. So it's 7 or 8. Huh. This 1 and 3 eliminates 1 and 3 from that cell there. So this is 2, 4, 6, 7, 8. Cannot be 5, 1, or 3. 8 can only be then 8 here, 7, 6, 2, and 4. So it cannot be here. This is a 1, 3 pair, which eliminates 1 and 3 in the rest of column 5. That leaves what? 2, 4, 5, 6, 8. 7 can then only be in 2, cannot be in 3, 4, 5, 6, or 8. Okay. These are digits 1 through 7. This cannot be 2 or 4 because there are different 2 or 4s that share the edge with this. So it's 1, 3, 5, 6, 7, 8, 9. That doesn't tell us much. Actually, this is 5, so that means 2 has to be in the 4th spot. sorry, 5th spot. 6, 4 has to be in the 6th spot. So this is 4. That eliminates 4 from these cells. This can't be 4. No 4, no 4. So 8 can no longer be in the 4th position. 1, 2, 3, 4. So this cannot be 8. 7 can no longer be in the 4th position, so this can't be 7. This 2 eliminates 2 here, so this is 4. Okay. This digit can be 1, 2, 3. Oops. 1, 2, 3, 6, 7, 8. So 6 cannot be in 1 because of the 1, 3 pair. Could be in 2, could be 3, cannot be 4 anymore. Cannot be 5, could be 6, 7, or 8. Okay. This is pretty convoluted. Just to show that this is a contradiction. Huh. This cannot be 9 here because this is 2 through 6 at most. So this is 5 or 6. No 7, 8, 9. 1 through 6, no 4. Where is the 4 then in column 3? And there has to be one because any 5 set must contain a 4 with 2. So then this is 4 here. Which eliminates 4 in the rest of the row. This can't be 4. This can't be 4. So one of these 2 is a 4 here. So this is 4. That's saying that the 4th has to be in the 2nd or 3rd position. It cannot be 2nd, so it's 3rd. So that's 3. Which means this has to be 4. So this 3, if this were, say, this cannot be 3 then. So this is 1, which makes this 3, which makes that 1. Wait, that's not allowed. Oh. Maybe that's a contradiction, right? These both are different 1s and 3s, and they both see that cell, so that's not allowed. Anyways, okay, what was that? That was assuming this was 7. Ugh. So that was pretty convoluted. Yeah, I'm not really still, I'm not grokking the, how do you say it? The underlying principles of tessellation yet. So this cannot be 7 here. Okay. Hmm. 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 Is there any cell? Oh. Okay, I see it. In this index line, you have the digits 1 through 8 guaranteed, right? Because they have to index some other point on the line, even if it's just itself. So these are the digits 1 through 8. But all of these cells see this cell here, right? This one sees it, and this is in the same column. This shares an edge, shares an edge, shares an edge, shares an edge. These share the same row. These share the same column. So you're guaranteed 8 different digits here on the index line, and they all see this cell. So therefore, this cell must be a 9, which means this has to be 5, 6, 7, 8, 9 to add up to be a Renban. Well, 1, 3, and 4 are removed from this possibility, so this is a 6, which makes this a 1 and this a 1. Right, because the 6th digit has to be where the 1 is. So this cannot be 1 or 6. No 1 or 6 here, no 6 here. This is then not 6, so 5 cannot be in it has to be in 7 or 8. This is 5, 7, 8. This is 5, 7, or 8. Well, again, 1 and 6 cannot be here anymore. This must have a 6 here. This is 1, so this cannot contain 8 in the rest of this row. This is 1, so this cannot contain 8 in the rest of the column and the row. We have a 5, 7 pair then in column 7, which eliminates 5, 7 in the rest of the column. So this must be 8, which means none of these could be 8. So 5 has to be in the 8th spot, so this is a 5, which means this can't be 5. That's 7, which makes that 5. So this can't be 5 anymore. 7 cannot be here because of the 7 in the row. This cannot be 5 anymore. This cannot be 5. No 5 here. So 5 is one of those two. Since 5, this is basically 2 has to be in the 2nd, 3rd, or 4th position, so this cannot be 2 here. So we guaranteed a 2 in one of these two, so this cannot be 2 here. Remaining digits in row 6 are 2, 3, 4, and 6. Okay. Remaining digits in row 4 are 2, 3, 4, 6, 7. These digits remain, so this cannot be 8. This has to be 2, 3, 4, or 7 remaining. And 7 cannot be in the 2nd position, so this can't be 2. Okay. Remaining digits in column 6 then are also 2 through 7. 2, 3, 4, 6, 7, 2, 3, 4, 6, 7, 2, 3, 4, 6, 7. This can't be 6 because of 6 in the row. These digits are consecutive. And if you have a 7 here, that's not going to be 3 consecutive with 2, 3, or 4. So this cannot be 7 here. So 7 can only appear, cannot be in 2 or 4. It has to be in 3 or 7. So you're guaranteed a 7 in one of these two cells. So this cannot be 7 here. This is 2, 3, 4. It could be with 1. It could be with 2 or 3, 4 or 5. Okay. Remaining digits in column 4 are 2 through 7. So this can't be 7. 2 through 7. This can't be 5 because one of these two is 5 here. So this can't be 5 here. This is 2 through 7 also, but no 6 because of 6 in the row. You have 2 through 8 here as a possibility. Cannot be 6. No 5. So neither of these can be 5 here. So one of these two is a 5. Since one of these two is a 5, this cannot be 5 here. Oh, this can't be 2, 3, or 4. So for the same reasoning, right? These cells share an edge with this cell. These cells see this cell by they're in the same row. This is in the same column. So this cannot be 2, 3, 4. It's guaranteed to be 7 or 8. So this must be either 3, 4, 5, 6, 7 for the 5 length rim band, or 4, 5, 6, 7, 8. So it cannot have a 2. So this cannot be 2. This cannot be 2. Six is in the 1 is in the 6th position. 2 can be in the 2nd, 3rd, or 4th positions. Okay. You cannot have a 6 here. If this was 6, the problem is this neither of these could be 5 here. Right? This can't be 5 because so 4 is only in 2, 3, or 4. So this cannot be 4. Interesting. So 4 is in one of these positions here, which means this can't be 4. We are guaranteed one of these is a 4, but we don't know which. This cannot be 1. There's no 8 possible here. So that means this could be up to 8. Well, we know one of these 3 here has to be an 8. Because none of these can be. Obviously, if that's 8, that doesn't affect anything else. We're guaranteed one of these is a 4. Okay. One of these 3 is a 4, so that doesn't tell us anything else there. This cell can be 1, 2, 3, 4. It could be 5 if this is 4 and 6. It cannot be 6, though, because that would have to be 6, 7, and 8, or 5, 6, 7, but neither of these could be 5 or 8. So this could be 1, 2, 3, 4, 5, or 8 here. Interesting. One of these 3 is guaranteed to be a 7, but that doesn't really tell us much. One of these 4 is guaranteed to be a 7, but that doesn't tell us much. One of these 3 is guaranteed to be 7. That still doesn't tell us much. 1, 5. Huh. Not sure what other test. We know one of these is 6. So that's not helpful. This cannot be 8. If this was 8, the problem is you'd have to be surrounded by 6 and 7. And I think the same problem is with 5. So if this is... that's not true. Never mind, that works okay. If this is 8, you have 6, 7, 6, 7. This 6, 7 matches that 6, 7. This 6, 7 matches one of those two. That's fine. Never mind. Um. Hmm. Yeah, we're just keep running into issues. Hmm. So 5 has to be one of these two positions here. That doesn't really tell us much. Hmm. Um. Hmm. 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 Um. Hmm. You have to think about the implications, I guess. Okay, what happens if this is a 7? That means 7 cannot be here. And this could not be 2, 3, or 4. So it would have to be 1 or 5 here. Well, you're guaranteed then 3 has to be one of these two. So this cannot be 3, it's 2 or 4. That seems fine. 2, 3, 2, okay. So this would be 8. This could not be 3 through 8, so this would be 5. Therefore, this would be a 4-7 pair here and here. So far that's okay. This obviously can't be 5 anymore. This is a 2, 3, 4 pair, so this cannot be 3. It's 1 or 5 there. 8 would eliminate 8 from being there, and this couldn't be 7 in either of these spots. 5 eliminates 5 here, so this would have to be 5 here. Which means this could not be 5 there. Um, 7's one of those two, so this can't be 7. This is 6, which makes this 7. So this would not be 7. This would not be 6. This 7 eliminates 7 here, so it's 4 and 7. So 4 cannot be here. So 2 can only be in 2 or 3. So this cannot be 2. This is 3 or 4. No 4 here, no 4 here. Seems fine. This can't be 6 anymore because of 6 in the column. None of these can be 6. Where is the 6 in row 4? It has to be here. So that's 6, which eliminates 6 here. Where is a 6 in row 6? It has to be here. So then this can no longer be 2 or 3 anymore. It's 4 or 7. It could be 6. Okay, so this can't be 5 anymore. It could be 5, 6, 5, 4, 6, 5, 4, or 6, 5, 7, or 6, 8, 7. So that's 5 or 8 guaranteed. 7 eliminates 7 here. So we have a 2, 3, 4 triplet, which eliminates 2, 3, 4 in the rest of the column. So this would be 6. This cannot be 6. We're trying to reach a contradiction, but this is looking like it might be the solution. Hmm. We have a 2, 3, 2, 3 pair here, which means this can't be 2, 3. That's 6, which forces this to be 5. And this must be 4 to be... That makes this 3, which makes this 2. So this must be 4. That makes this 1. So that's all seems to work. So this cannot be 4 here. 2 eliminates 2 here, so this is 3. So 2 is pointing in the second position. 3 must be in the fourth position. 4 must be in the third position, so that's fine. 1, 2, 3. This makes this a 2. So this cannot be 2 here. This cannot be 2 here. This all seems like it's kosher. Okay, so 4 cannot be in the second position, so this can't be 4. So it's a 2, 3, 2, 3 pair, which forces this to be 4. So this cannot be 4 here. This can't be 3 or 7, so it cannot be 3, 4, 5, 6, 7. So this is 2 or 8 here. Yeah, it's seeming okay. Okay, so this is probably not leading to contradiction and is probably the solution. So let's go the other way. I do like the index lines thing there, but this part I'm not sure how you solve it. Anyways, say this was 3, which means that 7 has to be here. This can't... Oh. That's a problem. Okay, so that's the contradiction there. Well, there you go. That shows the contradiction, because then this must be 2 and 4 to form a Renban, which forces 3 to be here, but the problem is this 3 eliminates that possibility. So this has to be 7. So we're going down the correct path. That's 7, then 8, which means this can't be 3, because 3, 4, 5, 6, 7 is the most you can get for 5-link Renban, and we have an 8 here. So this is 5, which means that 5 has to be in the 5th position, so this cannot be 5. This is 2, 3, 4, which eliminates 2, 3, 4 in that cell there, because they all share an edge. This must be 4 and 7. So 4 and 7, this must be 4 and 7. So yeah, we have all of that. So this 7 cannot be here. Same thing here. This cannot be 2, 3, or 4 because of the 2, 3, 4 triplet surrounding it. 7 cannot be either of these two. This can't be 5, which means this has to be 5 here. This is 6 or 7. 5 cannot be here. 7 has to be one of these two, so this can't be 7. That's 6, which makes that 7. So this can no longer be 6. This can no longer be 7. This can't be 7, so it's 4, which makes that 7. This can't be 4. So 2 has to be in the second or third position, so this can't be 2. It's 3 or 4. This 7 eliminates 7 here. This 4 eliminates 4 in the rest of the column. This can't be 6 anymore because of the 6 in the column. These can't be 6 because they're all sharing a cell with this, sharing an edge with this cell. So where's the 6 in row 4? It must be here, which eliminates 6 as a possibility here. So we give a 2, 3, 4 triplet in row 6, which eliminates 2, 3, 4 in the rest of the row. So this is 6. Again, this cannot be 2 or 3. It's 4 or 7. This has to be 5 or 8 with it. Because it's either 4, 5, 6, 5, 6, 7, or 6, 7, 8. This can't... Okay. So 2 is one of these two. Six cannot be any of these. So 6 is either here or here. Oh, this is 2, 3, 4 triplet in column 4, which eliminates 2, 3, 4 in the rest of the columns. So this can't be 2, 3, 4. It's 6, which eliminates 6 here. This is a 2, 3 pair in column 6, which eliminates 2 and 3 in the rest of the column. So this is 6. Therefore, this must be 5 and 4. So that's 5 and 4, which eliminates 4 here. This can't be 4, so it's 3. That's saying 4 has to be in the third position, so this is 4. This must be then 2. 3 eliminates 3 here, so that's 2. This cannot be 2. 2 eliminates 2 here, so it's 3. So this can't be 3. So 3 has to be in either the second. We kind of already knew that. So this is 2, 3, which forces this to be 1. This cannot be 4. This is 2 or 3. This is 2 or 3. 2 eliminates 2 here. So this is 3 or 4. 4 can only be in the third or fourth position, so this cannot be 4. This is a 2, 3 pair, which eliminates 2 and 3 in the rest of the row. So this can't be 2 or 3, so that's 4, which means this can't be 4 here. This cannot be 3 or 7. So if this is 3, 4, 5, 6, this would have to be 2 here, and it cannot be 2 here because of this 2. And then it must be then 4, 5, 6, 7, 8. So this is 8, which makes this 7. That makes this 4. So this is 5. This can't be 8. This 5 eliminates 5 here, so it's 1. 4 eliminates 4 here, so it's 3. That means 4 has to be in the third position. So this is 4, that's 2. That makes this 3 and 2 there, and that leaves this digit as a 2 there. Yeah, okay, so I should have been able to spot the index line earlier, all eliminating that cell, and then also eliminating that cell. I don't know. I don't know if I would consider this easy, though. Maybe I just don't have the nuances of tessellation yet, so it's kind of hard to see these things. But, and then, yeah, I went down this path and it's like, oh, it's a solve path instead of actually a contradiction. But I don't know how we could have, I mean, obvious, once I saw it, once I tried it, having 7 there, it was obvious contradiction. But sometimes it's kind of hard to see. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.